So this one is actually depicting a real processing, like multiprocessing system, SMPs, one type of SMPs, and it's kind of showing that how they share different resources like memories and I/O devices among different processors. So let's say we have like multiple processors, and each processor has their local memories. We call it a cache, and we'll see it in the memory module when we study memory module. But for time being, this cache or L1 cache, L2 cache, just take it as a local memory at different level, different hierarchies. Now these processors have their internal L1 cache, local memory, and that can be connected to another kind of local memory kind of thing like L2 cache we call it. And then that L2 cache is connected to something called a like a bus, which is shared between the different resources. What does it mean? You have different data resources like main memories and IO devices like keyboard, mouse, printer, all the memory extension, USB system, and etc. etc. So all of them are connected to a central bus, which is drawn as a rigid black central line in this schematic diagram representation. This bus is nothing but like several electrical lines, like several wires, and each of these components, along with all the processors, are connected to those inactive inactive wires in the bus. Okay, so a bus is nothing but multiple wires. It can be like 128 number of wires, like in terms of bit, 128 bit, 256 bit, etc., etc., depending on the need of the system, but they are all connected to that piece of electrical wires. Okay, multiple piece of electrical wires. Now, when let's say a processor wants to get some data or write some data into main memory or IO device, what it does, it basically requests the system that, hey, I want to grab the bus and send out some data. Let's say it's trying to write down some data into the memory. So first processor, let's say it wants to do that, it sends a request to the system that I want to send some data through the bus, so please grant me access. Likewise, all other processor also can send their request. But this system, which is by the way called a bus arbiter system, it allocates, like through some polling process, it kind of decide, okay, this processor has a high priority, this processor has low priority, and so on and so forth. It allocates one processor at a time to grant an access to the bus. So then what processor, whatever got the grant on the bus, only that processor go and sends out data and control for the target device. Okay. While at the same time, other processors kind of wait. They sent their request to the bus arbiter system, and they wait till it gets a grant from the bus arbiter. So that means only one processing system can actively use this bus, this set of electrical wires. They can only, one of them only can use at a time. So that processor then can sends out a request for any of this connected component like main memory or any IO devices. So how does it do it? So that means first step the processor needs to do is to send out a request for a target device. So it need to say that, hey, I am going to access main memory, or I am trying to access my keyboard, or I am going to access my disk driver. Okay. So each of these device has an unique ID associated with it. Okay. And the processor first go and create a request containing that unique ID, so that only that corresponding device will answer to the request. And with that ID followed by that, it can have like, okay, please give me data from this address to this address, and so on and so forth. It can have different type of request, either read or write request to those target devices. But the point is that there has to be certain protocol through which this request has to be sent out for the other devices from the processor. And there are several such protocols which is not in the scope of our study, but just to for information that there are protocol of sending and receiving data through any shared bus system. The basic need for that is this: to address correct or right device for data exchange. And the data exchange can be either read or write, doesn't matter. But point is that it has to be certain protocol, because like you initiate a data exchange, let's say with the main memory, and you can request for not only one single data, but you'll request, let's say, for 1 megabyte amount of data, right? Then this memory system also need to know, like start that data sending out this one memory byte by byte, maybe word by word, okay, depending on the system configuration. And at some point of time, it need to flag out, say, hey, I'm done with that, with my data sending, right? So there has to be certain like sequence and protocols to be followed for this communication between different hardware components. So once such like operation is done and that corresponding device flags that I am done, then processor recognize that done and say to the arbiter also that, hey, I'm done. Okay, so you can actually go and grant the bus to the next processor waiting in the queue. So this arbiter maintains a queue of requests from different processor, and it stays there till it gets a grant from the arbiter. So first processor got a grant, started data exchange. Data exchange is done. It says to the arbiter, say, hey, I'm done. Then arbiter go to the next processor in that queue. And we usually maintain a priority queue, and each processor can be assigned with different priorities. And if higher priority processor request comes in, they basically bypass the queue, go in the front. Lot of different protocols can be developed in that grant and access request for the bus. But the central theme here is that all the data exchange are going through some common electrical wires in the system. That's the backbone of the whole system. That's the central theme. So, feature of such system, shared bus system, first of all, modules must be distinguishable. As I was saying, that a processor needs to know unique IDs of each of these systems, like memories, keyboard, mouse, etc., etc. So that they are distinguishable, and it can actually send out requests targeting to one specific device with that request, so that that specific device only responds, right? Arbitration is to arbitrate competing requests for the bus control, as I described earlier. There is an arbiter. It can be an hardware system, it can be an operating system software, etc., etc. That really doesn't matter at this point. And time sharing, so exclusive access to the bus to the single component, or we call a master. So here all the processors are the masters, where other, or you can say it's a non-master. Slave is not a right term there, but it's not a master. It cannot start a grant request. Okay, arbiter is only talks to the processor. It doesn't talks to memory system or IO subsystems. It only talks to the processor. The processors really are the masters, and they get exclusive bus control at one point of time. Okay, and this bus is time shared. So advantage is it's a very simple system, similar logic for connectivity as in single processor system. Okay, so in single processor you have a dedicated data bus, like going from that 32-bit going from processor to memory unit. It's the same thing from the processor perspective. You are basically connecting to the 32-bit for the address and 32-bit for the data, some control bit, maybe some extra bit for that request protocol connection and stuff like that, but it's kind of a very similar way. It's a flexible, easy to expand the system. You just plug in to different IOs, different memories into the system. Just you have to have those devices have to have a unique ID. And as I said, it's a passive system of connection. Like there is no active element in the bus. It's just a piece of wires. Like multiple 120 to 256 number of wires just laying down, and every other active system is being connected to those wires. So device failure scenario, basically if it occurs, let's say one of the memory fails, it can still work with the other memories. It will just reduce in the number of memories. Or one of the IO device fails, well, your mouse fails, your trackpad still works. Your trackpad fails, mouse still works. So that kind of failure scenario is very kind of protected against that scenario. Like your whole system won't go down. Just one is not working. What can I do? Every other system will work. So it is much reliable.